Hello, my name is David Coffland. I'm from Idaho State University.
And I'm Sacha Johnson. I'm also from Idaho State University, and today we're going to talk to you about our research project, Scenario-Based E-Learning and Feedback Effects on Learning Outcomes and Motivation.
Our study examined the effect of two independent variables, scenario-based e-learning, its use and non-use, and feedback type, specifically elaborative and intrinsic feedback, on two dependent variables. The knowledge test that was researcher developed was used to get the knowledge scores, and the Keller's IMMS was used to measure motivation.
Brown, Collins, and DeGewitt asserted back in 1989 that in traditional classroom settings, learners may be able to pass exams, but are not able to use that conceptual knowledge in practice. So just because we learned something in the classroom doesn't mean we can actually use it outside of the classroom. According to Brown et al., this idea of situated learning, also called authentic activity, is important for learners because it's the only way they gain access to the standpoint that enables practitioners to act meaningfully and purposefully. Scenario-based learning and scenario-based e-learning grew out of that idea that situated learning provides context for how information will be used in the real world, and in 2016, Clark suggested that scenario-based e-learning can lead to better transfer to tasks different from those used in the training and to greater long-term retention. Regardless of instructional approach, feedback is provided to help improve student confidence and show learners how to take corrective action. Feedback has also been found to be a powerful influence on student learning outcomes and has been found to be especially important for computer-based instruction. However, according to Leckermeyer and Fasnacht, a conclusive overall picture on feedback characteristics effects is missing. As Keller indicated in 2010, the history of the study of motivation is long and deep. Similar to the study of feedback, there's a tremendous amount of research on motivation, but according to Keller, there's little guidance for those who want to be more effective at motivating learners, so he developed his ARCS model, which stands for Attention, Relevance, Confidence, and Satisfaction. He believes by addressing these elements in instruction, we can create motivating instruction. Because of the limited time here, this literature review is highly compressed, but we've included some additional references in the references slides if you'd like to explore any of these areas further.
This study made use of a repeated measures design with two different between groups factors, each of which had two levels. So we basically did a pre-test, an immediate post-test, and a delayed post-test on this 2x2 array of scenario versus no scenario and intrinsic versus elaborative feedback. The instruments used in this study were Keller's IMMS, the Instructional Materials Motivational Survey, and the researcher-created knowledge test. The survey is a 36-item self-report measure of students' attention, relevance, confidence, and satisfaction. It has been described by Keller. The knowledge instrument was also measuring some performance, was developed with faculty from the medical lab science programs. It was designed to measure whether students could recall the procedure as well as counting sperm cells accurately and doing the necessary computations to report an accurate total cell count. Content validity was established using the Delphi method with those experts from the content area. Each instrument was administered to the subjects at 3 times. The first as a pretest for both motivation and for the content knowledge. There was an immediate post-test where the motivation instrument was given immediately after going through the learning materials, followed by the content knowledge post-test. Then, approximately 2.5 weeks later, both the motivation and the content instrument were given again, thus providing us with our repeated measures, a pretest, an immediate post-test, and a delayed post-test.
The two scenario-based treatments put learners in the context of landing a job in the medical laboratory and performing duties as guided by their new supervisor. The scenarios were based on true laboratory tests and real patient samples. As you can see here, the scenario-based lessons started out, "Congratulations, you've just landed your dream job in a medical laboratory, and one of the first tests that has come in is a semen analysis." Then the lesson leads learners into the patient scenario and what they will be doing as part of their new job. The two treatments without scenarios were designed with straightforward information, so they didn't have the context of working in a real lab. The instruction for these treatments started, "This lesson is designed to show you how to manually count sperm cells." It goes on to explain what the instruction will cover. All 4 treatments contained the same information, but it was presented differently based on the scenario level, present or not. One of the 2 feedback types was elaborative, as shown here. It informed learners of whether their answers were correct or incorrect, and also included some guidance on where they might have gone wrong and how to rectify that mistake. Elaborative feedback was presented without any context of the medical lab. Intrinsic feedback, on the other hand, provided learners with the correctness of their response as well as the impact of their responses as an employee in the medical lab. For example, not being able to keep their dream job, or what may happen to a couple after receiving this cell count along with the rest of the results of their analysis.
The primary intended audience for this training were medical laboratory science and medical laboratory technician students in a number of different institutions across the country, so that their real world scenarios would actually apply to them in the future. However, data were collected just as COVID was starting to make its impact felt across the country. As a result, only the home institution of the researchers remained in the study. And so those 48 that started out iteration 1 of the training were all of those students in the class during the school year. Therefore, we had to try to gather other groups, and they turned out to be not all medical lab science or medical lab technician students. And 3 different efforts were made, starting with 17, 14, and 5 students apiece. However, the number of completers was actually fairly high in each iteration. So that only gained us another 21 subjects. As a result, we are considering this something of pilot test data and moving on with that idea in mind. Our sample, as you can see from this table, is mostly non-traditional, with 60% of the students being age 25 or older. It's also just shy of 2/3 female. And most of the participants, just under 60%, were medical lab scientists or medical lab technologists, and that group, putting those 2 groups together, gave us a little under 62%. Now, each of the N's in this case represent 84 as a total, which is the number of people who began the training in the study, not the number of completers. Because of human subjects concerns, the demographic data were not collected at the same time or using the same technique in the learning management system as the knowledge and motivation data. Therefore, we could not remove the demographic data of the non-completers. So this is an approximate, at best, set of percentages for what the actual sample of 66 participants that completed the study actually represent. As you can see, 77 out of the original 84 starters had already taken an online course. 2/3 of the group had previously used Moodle, which is the institution's learning management system. And an even greater margin, 79 for 94%, had experienced taking an online exam or assessment of some type. We also wanted to know if they had previous manual cell counting instruction. 81% did not, 14% did. Once the data were collected, descriptive statistics were computed, and then a pair of 2x2 repeated measures ANOVAs were conducted, one on achievement and one on motivation. We chose not to conduct a single multiple ANOVA, a MANOVA, because we were running into problems with our power. And when we looked at doing a MANOVA, the power basically disappeared. We then also did a chi-square test of independence on cell count mastery, which was defined as being within 1 standard deviation of the expert's cell count numbers.
Here are the results of the 4 treatment groups for research question 1, which was participants' content acquisition and cell count accuracy over time. The data were analyzed with and without 3 outliers identified in SPSS, and both analyses yielded similar results. The actual statistical values are included in the notes for this slide, which will be made available with this recording. The knowledge test had a maximum score of 10 points. No statistically significant effects were observed for scenario level, present or not, or feedback type, elaborative or intrinsic, nor was an interaction effect observed for these 2 independent variables. However, there was one statistically significant result, which was for time. Pairwise comparisons using a Bonferroni adjustment saw a statistically significant increase from the pre-test to the immediate post-test, which would be expected as a result of the instruction. However, a statistically significant increase was also observed from the immediate post-test to the delayed post-test, which was somewhat unexpected because of the 2-week delay between those 2 post-tests. Because we were also interested in participants' ability to perform manual cell counts accurately, we ran a chi-square analysis to look at the mastery of participants' ability to perform the counts. As Dr. Coffland mentioned, correct answers were defined as within plus or minus 1 standard deviation of the mean of expert counts. And mastery was defined by answering at least 2 out of 3 cell count questions correctly, whereas not having met mastery was defined by answering 1 or fewer cell count questions correctly. The results of the chi-square analysis showed no statistically significant differences for the immediate or delayed post-tests, and the treatment conditions did not appear to have an effect on participants' accuracy of manually counting sperm cells. In contrast to the results on the content knowledge scores, the participants' skill mastery dropped between the immediate post-test and delayed post-test, which would be expected after that 2-week delay. For both the immediate and delayed post-tests, higher mastery levels were observed when intrinsic feedback was paired with scenarios and when elaborative feedback was paired with no scenarios.
For research question 2, which addressed motivation, there was exactly one statistically significant result, and it was a time-based significant result between the pre and the immediate post administrations of the IMMS, the motivation instrument. In this case, the pre-test scores went down from an overall average of approximately 141.7 to an overall average of approximately 133 or 134. That was considered to be statistically significant. In the delayed administration of the motivation instrument, there was a rebound in motivation scores that were lower in numerically than the pretest levels, but were statistically equivalent to both the pretest and the post-test levels.
Although no statistically significant differences were observed for research question 1, by examining these line graphs, we can see an apparent interaction effect. For the scenario groups, participants who had scenarios with intrinsic feedback had a lower starting score, but then they were able to catch up to the participants who had elaborative feedback on the immediate post-test and then actually surpass them on the delayed post-test. For the no scenario groups, those who received intrinsic and elaborative feedback had similar means on the pretest and immediate post-test, but those who had elaborative feedback appeared to score higher on the delayed post-test than participants who had intrinsic feedback with the scenarios.
In our interpretation of the results of research question 2, we have to remember that with the relatively low end compared to what we were going for, we're considering this as pilot test data. And so nothing definitive should be concluded from this. However, it may be of interest to note how this data is going for future research. As mentioned before, the motivation scores went down significantly from the pre-test to the post-test administrations, the immediate post-test administrations of the IMMS. And then they rebounded somewhat on the delayed post-test administration of the IMMS. When we break these out by the different groups, we notice that there is one group that did not rebound and actually slid about 0.3 of a point. And that was the scenario group with elaborative feedback. We should also note that the 2 largest drops in overall motivation scores were the 2 groups that both had the scenarios. The scenario with elaborative and the scenario with intrinsic feedback both dropped approximately 9 points, which represents about a 7% drop overall. The no scenario groups One group dropped 3 points, while the other group dropped about 5 points, representing something along the lines of 1% and 1.7%. The overall drop may be due to the fact that participating in a study might be motivating to students in some way, but the actual doing of the computation of something that may be a bit difficult drops motivation somewhat. And then afterwards, they realized, no, this is not a bad thing to know, perhaps, and so motivation came back up, except for that one group. So a couple of possible things that might be worth future study here. We'll talk more about the future study later. But the idea that the potential real-world consequences of tests that did not go the way that the potential real-world clients wanted them to go, the delivery of bad news, in other words, might be a demotivating factor for the students who were going through the scenario versions of the study. And as a result, if we look at the scenario with the elaborative feedback, that group stayed low. They were simply saying, okay, we're providing some negative results, whereas the scenario with intrinsic feedback rebounded much like the other groups did. This may be worth future study. We'll talk more about this in the next slide. The other thing to recognize is that one group, the scenario with elaborative feedback, didn't rebound at all, while the other three groups did. And so this would imply, once again, as a potential conclusion, that we might consider only using intrinsic feedback with scenario-based e-learning.
Looking at the results of this study as more of a pilot test due to the low number of participants, it appears the learners in all treatment groups increased their knowledge of manual sperm cell counts regardless of the scenario level or feedback type, from pre-test to immediate post-test, and again from the immediate post-test to the delayed post-test. It is possible this increase was due to the immediate post-test acting as a subsequent learning opportunity. Further, the participants appear to have learned recall, but not application, which actually decreased from the immediate to the delayed post-test. This could indicate that without sufficient skill practice, the skill was not necessarily learned. As mentioned, patterns did seem to emerge, although they were not statistically significant. If future research supports those patterns, a possible recommendation would be to pair intrinsic feedback with scenarios and elaborative feedback without scenarios for optimal knowledge acquisition. Future research with more participants and in different disciplines is recommended.
Our conclusions about motivation in the study need to be viewed through the lens of pilot test data. And as such, we don't know if we will see something in a follow-up study. However, it does seem to be that the motivation dropped immediately after the training and then rebounded somewhat for the delayed application of the IMMS. This might be indicative that some subject matter content, it might be considered difficult or hard to learn or not interesting, and thus causing a drop in motivation because of lack of relevance, lack of confidence, or lack of satisfaction, since we're going back to the ARCS model on this. And that we need to see if this pattern holds in other places. Now, there's also some indication that the scenarios cause more stress, which could be a factor in reducing motivation scores between the pre-test and the various post-tests. The possibility is that the real world, or realistic, if you prefer, consequences of the test itself or of getting the test incorrect add to the realistic pressure that the students or the learners feel while taking those tests. That might be something worth looking at as well, especially across a range of topic areas. Those things where negative results can have a relatively large impact on real people's lives. And finally, there seems to be the flattening out effect of the scenario with intrinsic feedback that caused motivation to drop and not rebound. It actually slid just a little bit lower. This may mean that there is a possible future recommendation after it's confirmed by future research that recommends specific types of feedback if scenarios are available. And this ties into that idea of pressure with the idea of perhaps we need to provide some form of mentoring to students who do these high stakes tests in their real world potential jobs to say, things happen. And it's better for us to know the truth than to give them pleasant but incorrect results.
These slides include the references for our presentation, as well as some additional ones that may be of interest to others who'd like to explore these topics. I'll leave each slide up for a few seconds in case you'd like to pause the recording. You'll also find the references on the handout slides. Feel free to reach out to myself or Dr. Coffland if you'd like to know more about this research study. Thank you for your time.